Okay, so section 3.2 introduces the concept of the mole. So when you're looking at your atomic mass periodic table, so the new periodic table I call the atomic mass periodic table, you're going to notice that all of the atomic masses underneath every single element are already rounded to the hundredths place for you. So that means you will always use them to the hundredths place. And those values are the grams of that particular element in a mole of that element. Okay, so what is the mole? Well, it doesn't really make sense for us to use a dozen because a dozen would be too small of a quantity for all the atoms and molecules that we have in a sample. So chemists work with something called the mole. It's kind of like our version of a dozen. You can abbreviate the mole as MOL, so you can omit the E. And a mole is the number of atoms in the atomic mass of an element in grams. So what that means is when you guys look at the periodic table at hydrogen, which is 1.01, okay? In 1 mole of hydrogen, this would be equal to 1.01 grams of hydrogen. Okay, so I could use this to convert between grams and moles if needed. Okay, same thing goes for oxygen. Oxygen is 16.00. So that means if I have a mole of oxygen, this would be equal to 16.00 grams of oxygen. Okay, if you round off your molar mass or your atomic mass on that periodic table, you run the risk of getting a different final result, and that final result may not match what I put into Canvas. Okay, so just make sure that you don't change these numbers. Okay. Okay, now, the number of things in a mole is also referred to as Avogadro's number, not because Avogadro came up with this concept, but it's in honor of him, okay? Now, just like a dozen is 12, the mole or Avogadro's number is 6.022 times 10 to the 23rd, and it keeps going and going and going. But what we're going to use is 6.02 times 10 to the 23rd whenever we're doing our calculations. And you'll see me writing this up, repeating it out loud constantly. Okay, so basically a mole is equal to 6.02 times 10 to the 23rd things or items. And in chemistry, those things are going to be atoms and molecules or ions, or something called formula units. And I'll go over each one of these. Okay, so what I'm introducing here are two different methods for unit conversions. Let me show you why. I'm showing you that we can convert between moles and grams. I'm also showing you that we can convert between moles and atoms or molecules or ions or formula units, depending upon the situation. Okay, so in this section, we will introduce one-step conversions. Then I'll bring these two together and I'll do two-step conversions in the next section. Okay, so that's why I say this section and the next section go together. There's really nothing different that I'm going to be teaching you. Okay, okay, now, in the early 1900s, the mole was introduced by Wilhelm Ostwald. You can turn to the next page, and we're going to jump straight into some conversions. Okay? Okay. So what we're going to take a look at first is doing conversions between moles and items or things, atoms, molecules, formula units, etc. Okay, and in order to do that, we need to use 6.02 times 10 to the 23rd. So if I'm converting moles to items, we would use this fraction, which I will be writing out repeatedly, to do it. If we're converting things or items to moles, then we would multiply by this fraction. Okay, so the number 1 will always be next to moles in the unit equation. And then 6.02 times 10 to the 23rd will always be next to the items or the things. So if those items are molecules, atoms, ions, or formula units, that's where you would put it, okay? So let's take a look at the practice problems on the next page. So on the next page, we've got chromium ions are responsible for the beautiful colors of rubies and emeralds. How many chromium ions are in 3.5 moles of chromium ions? Okay, so this is what we are given. We are starting with moles. It would be considered improper for you to write out chromium ions in words. Chromium ions are the Cr+3, so we want to make sure that we abbreviate that when we do the setup. And then we're solving for how many chromium ions. So this is what I'm going to solve for. So we've got 3.5 moles, and then put the symbol. Always put the symbol rather than the word of the substance. And then this is going to be times moles of chromium ions needs to follow you onto the diagonal like this because we need to cancel it. So those need to match. And then we're solving for chromium ions. So I'm going to put Cr+3 ions on top. Now, the number 1 always goes next to moles. So in the fraction, where would I put the number 1? Yeah, on the bottom because that's where moles is. Okay, number 1 always goes next to moles. And then since ions is an item or a thing, this is where you're going to put 6.02 times 10 to the 23rd. Okay, in your calculator, we're going to multiply across. So this is going to be 3.5 times 6.02 second E 23, enter. In terms of significant figures, you have 2 significant figures in 3.5. The number 1 has infinite sig figs, and then this would be 3 sig figs. So we go with the fewest, so I want 2 sig figs in my final answer, okay? I got 2.1 times 10 to the 24th. Make sure that you guys can get that in your calculator. Okay. This is a really large number. You would absolutely never write that out as an ordinary number. Okay, it would always be in scientific notation. All right. All right, do you want me to do another setup and then you guys can try one on your own? All right, let's try number 2. Number 2 gives you 30 moles of water. We're looking for molecules of water. Okay, so this is what I'm given. I'm starting with moles, and then this is what I'm solving for. Molecules, which is an item or a thing. So we're going to write 30.0 mole H2O. Remember, we need to cancel this unit. So this unit needs to follow you onto the diagonal. So this will be moles of water. And then you're going to put molecules, which you cannot abbreviate molecules because it looks too much like moles. Okay? So you always have to write it out. Where would I put the number 1? Yeah, on the bottom next to moles. And then molecules is an item or thing, bless you. So we're going to write 6.02 times 10 to the 23rd on the top next to it. We're going to multiply across. You have 3 sig figs in 30.0. The number 1 is infinite sig figs. 6.02 is 3 sig figs, so you want 3 sig figs in your answer. Your answer will be 1.81 times 10 to the 25th. And then this is molecules of H2O. Okay, so this would be your answer. Okay, you do number 3 and let's see what you come up with. Did you guys get 1.4 times 10 to the 22nd? Yeah.
Is it wrong to write Na atoms?
You could do that. We good? Yeah.
Would it be wrong to write out sodium as a
It just would be improper. Okay. Okay, can I go on? Okay, so we can go in the other direction. So let's come down to the bottom of the page. I'll do one of these for you. So down here, it says incandescent lights are filled with argon to prevent the glowing filament from burning up. How many moles of argon do 1.81 times 10 to the 22nd atoms of argon represent? So here you are given atoms, which are items or things. We are solving for moles. So we're going to go in the opposite direction. So 1.81 times 10 to the 22nd atoms. Argon is Ar. And then we're going to put atoms of argon on the diagonal because we need that unit to cancel. And then we're going to put moles of argon up on top. Number 1 goes where moles is. Since moles is on the top, I would put the number 1 there. Atoms is our item or our thing, so we're going to put 6.02 times 10 to the 23rd on the bottom. Be super careful when you put this in your calculator. This is a number in scientific notation, and so is this. So don't put that multiplication key in when you're entering those. This is going to be 1.81 second E22 divided by 6.02 second E23, and then enter. 3 sig figs is what you would want. You should get 0.0301 moles of argon. Okay, do you guys want to try one of these on your own? Try number 2, and let's see what you come up with. Okay, so if you didn't get 3.74, you probably put a multiplication symbol in there somewhere, and then it's just dividing out the wrong numbers. Okay, do you have any questions for me on this, or are we cool? We're good. Okay, awesome. Let's go to the next page then. Okay, so what we're going to do, let me stop this video.